Now, what I want to do next is graph decay models. They're very similar to graphing growth models. If you recall, the graph of an exponential function, a times b to the x, will always pass through the point 0, comma a, and it will always have, if there's no shifting, right, it's always going to have the x-axis as an asymptote. The domain is going to be all real, and the range is going to be all y values that are greater than 0 if the a value is positive, and y values that are less than 0 if the a value is negative. Really, everything that I just said is the same thing from section 8.1. Nothing has changed. However, the look of the graph will be a little different. We've never graphed ones quite like this. By the way, if you look at A, let's just think about if this is growth, decay, or neither. Our A value is -2. Hopefully you recall this, if your A value is negative, if it's less than 0, this is actually neither growth or decay. And actually, because our base is 1/3, which is between 0 and 1, right? This is like a decay model, which if we had an image in our head of what decay looks like, it's like this. However, whenever your A value is negative, it's going to be a reflection of that graph over the x-axis. So if you were to go ahead and take a reflection over the x-axis and flip that over, you'd get something like that. So I kind of know already that this graph is going to look something like the guy here in orange. Now, it helps that I have experience, right? You don't maybe know that yet, but you soon will. Let's graph this. I'm going to plot a few points. If we plug in 0, we'd get 1/3 to the 0, which is 1, and we would get an output of -2. So I'm going to plot 0, -2 right there. If I plug in 1, then I'd have, let me just maybe write it over here if it's okay. I'm going to erase some of this stuff that I had done before. So if we had plugged in 1 again, this would be -2 times just 1/3, which is -2/3. So if I plug in 1, -2/3 is like -0.7 if we had to round to one decimal place. Now, rather than plug in 2, I'm going to plug in -1. I kind of like plugging in 0, -1, and +1 for these guys, as you'll soon see why. If I plug in -1, I'm going to have -2 times 1/3 to the -1 power. Now you know if you take 1/3 to the -1, you'd have to flip that base because, let me maybe really analyze this so everybody's clear. If you have -2 and we distribute that -1 power to the 1, it's going to be 1 to the -1 and 3 to the -1, which means you have to flip them. So it's going to be -2 to the 3/1 power, which is really just 3. You'd get out -6. So that's kind of a nicer coordinate to plot than if we were to plug in 2. I think if we plugged in 2, we'd get some really small decimals. So here I can plot a nice -1/6. Now keep in mind the x-axis is our asymptote, and we start low and we're going to come on up and flatten out and approach the x-axis as we go to the right, and it kind of falls down as we go to the left. Your domain is going to be all reals, and our range is going to be all y values less than 0, and that's because the graph is underneath the x-axis, and that's due to that negative in front of the 2, right? It's a -2 for our leading coefficient there. Let's look at another graph. Here, this one's got some shifting. So this is kind of like what we had finished the last section with. If I were going to graph this and make my life easy, I'm going to ignore all that stuff right there first and graph only my parent function. So this is our parent. Our parent is y equals 5 times 1/8 to the x power. Let's plug in a couple values here. If you plug in 0, you're going to get 1/8 to the 0, which is 1, and 1 times 5 is 5. So you can plot 0, 5. If you plug in 1, you're just going to have 1/8 to the first, which is an eighth, times 5 is 5/8. And then instead of plugging in 2, I'm going to plug in -1. And if you plug in -1, remember, that's going to be like 5 times. We'd have to flip the 8/1 or excuse me, the 1 over 8 to be 8 over 1 if we had applied the negative exponent. And that would actually give us, what, 40? Maybe that wasn't the best after all. That's way, way up high, right? Let's try 2 after all. If we do 2, it's going to be 5 times 1 over 64 if you square 1/8. And that's a really small value. That's going to be 5 over 64. That's so small, it's pretty close to 0 as far as graphing is concerned. So if we plot these points, we have 0, 5, right? So 0, 5 is right here. When we plugged in 1, we got 5/8, which is just a little bit more than half, so ballpark right there. We plugged in 2, it was even closer to 0, so you can see these points kind of fall down pretty quickly. And by the way, this is a decay model. Our A value is 5, bigger than 0, and our base is a number that's between 0 and 1. It's 1/8, right? So it's definitely decay, and we can see that as these points are falling from going left to right. Now, what I need to now do is shift. Remember, this is not our final answer. Our H value in this problem is really a -1, so that means 1 to the left. And our K value is really -2, which means 2 down. So we're going to translate or move these points all 1 to the left and 2 down. Let's start with this guy. 1 to the left and 2 down. Right there is my new point. If I go this guy, 1 to the left and 2 down, it's going to be about right there. This guy, 1 to the left and 2 down is right there. Now remember, when we go any vertical shifting on these, the asymptote also gets shifted. So we went 2 down, the asymptote that was the x-axis now got shifted down 2 as well to y equals -2. That's our asymptote. So if I were to clean this up, really the graph that we want to have for our final graph is going to start up really high, and it's going to come down on a smooth curve. Now this one bends so quickly that it's going to almost look like a sharp edge. It's hard to not make it look like a sharp edge, but we get some kind of graph like that, where a decay is going from left to right. Let's talk about the domain real quick. The domain would be all real, and the range would be all y values that are strictly greater than that asymptote at -2, because we have all y values above it.